So in this video, we'll be going over problem 2 from the note packet, which was the medical application problem. So let's start off by reading the problem and highlighting some important parts. A man is driving his car at a constant velocity of 23.59 meters per second. So we're going to highlight that part. When he is suddenly stopped and his brain comes to a stop in 0.356 seconds. So we have a time interval here, comes to a stop, that's his final velocity, and then it says to calculate the acceleration experienced by the brain. So we are looking for an acceleration. So the man's driving along, so this is just a one-dimensional problem since he's just going along a road. So this is a 1D kinematics problem. Let's specify a coordinate system. So I'm going to choose that to the right is the positive x direction. Of course, you can choose to the left. You just need to stay consistent. So specify a coordinate system. From the problem, we know that we are asked to calculate the acceleration experienced by the brain. So we are solving for acceleration that has units of meters per second squared. And let's think about what the sign would be. So we are moving along to the right and the car is suddenly stopped. So to be able to slow down, we know that acceleration must be in the opposite direction of velocity. So if we're moving to the right, the acceleration must be to the left, and so we should expect a negative acceleration. Moving at a constant velocity, so we should have evenly spaced dots on our motion diagram to represent that. And then the car comes to a sudden stop, and the brain accelerates to the left. So we have a decrease in velocity. So that means a closer spacing of the dots. And this is a pretty fast process. And so that's our final position there. Start labeling the information from the problem onto our motion diagram. So we're going to choose the initial position to be the point just before the stopping time frame. So that's going to be this point right here. We'll go ahead and call that x naught is equal to 0 meters. And then we are given that the velocity is constant to the left of this point. So we know that that velocity must still be the same. So the initial velocity is equal to 23.59 meters per second. And now for the final position, I'm just going to give myself a little more room, just add another dot here. The final position, we know here, we know that the person's brain comes to a stop. So we know that the final velocity is equal to 0 meters per second. Not given any information about the position, so we're not going to include that. The other information that we have is that the brain comes to a stop in 0.356 seconds. Now that time is the time between just before the stopping period and then the final stopping period. So that is this time frame that I just outlined. So delta t is equal to 0.356 seconds. Now, in that same region is where the acceleration is taking place. So that's the quantity that we're looking for. So we'll also put that up here. The acceleration is a question mark because that's what we are looking for. We're expecting units of meters per second squared. And again, since the velocity is to the right, which is positive, and we're slowing down, we know that we should expect a negative acceleration. So now that we've drawn a diagram and we've identified our knowns and unknowns, we can plan our solution. So we know our initial and final velocity, and we know the time interval that all that happens at, and we're looking for an acceleration. So looking at our kinematics equations up top here, we know that the third equation, this bottom left equation, is going to satisfy that. So we have our final velocity is equal to our initial velocity plus the acceleration multiplied by the time. Just checking off what we know and don't know. We know the final velocity, we know the initial velocity, we are looking for acceleration, and we know the time. So we have one unknown, and we have one equation. So we are good to solve. On the hard part, all we need to do is just execute our plan. So starting from our equation that we put into 2, we have the final velocity is equal to the initial velocity plus the acceleration multiplied by time. Substituting what we know and don't know in, the final velocity is equal to 0 meters per second. The initial velocity was 23.59 meters per second. We are looking for acceleration, and all of this is happening over the time interval of 3.56 seconds. So separating out and getting acceleration on its own, we'll subtract 23.59 over. So we now get a negative, and that's divided by time, which is 3.56 seconds. And so now we can combine units. The seconds up top goes to the bottom, and our final result is an acceleration of negative 66.3 meters per second squared. So let's take a look. We're looking for acceleration, so our solution's complete. The sign of the answer is negative, and again, we are expecting a negative acceleration since it was slowing down. And so acceleration needs to be opposite the direction of velocity. Units of meters per second squared, which is the units for acceleration, so we're good there. And so let's see if this is reasonable. A velocity of 23 meters per second is roughly 55 miles an hour. So if you're on your highway and you stop in less than half a second, you would expect to have a large acceleration as a result. So this does seem reasonable.